Now let's learn how to find tangents to polar graphs. So the question is, what is the slope of the line that's tangent to a polar graph? And let's say we have this polar graph that's just a circle, r equals, let's say this is 2. What is the tangent at this point? So basically what we're going to do is use the fact that this slope is going to be dy dx. Now, a polar graph is in terms of r and theta, so we don't have this y and x. So we're going to have to use these identities that y is equal to r sine theta and x is equal to r cosine theta to find dy dx. And how we can use this is that through these equations, we can find dy d theta and we can find dx d theta. And look at what happens when we divide those, dy d theta and dx d theta. We get the dy dx that we need to find the tangent. So let's just go over how this is going to look. And this is going to be a generic formula that you guys are going to probably want to memorize. And all that's going to change is the equation of the polar graph. So let's go ahead and do that. So to find dy d theta, we have y is equal to r sine theta. So what is dy d theta? And this is pretty much a product rule. We have two parts. We have r and we have sine theta. So the product rule tells us that we have to take the derivative of the first part, which is going to be r. So the derivative of r is dr d theta. And we're going to multiply it by the second term, which is just sine theta. And to that we need to add the first term, just r, times the derivative of the second term, and the derivative of sine is cosine theta. Now let's just do that again for x. If x is equal to r cosine theta, then dx d theta is just going to equal to the derivative of the first term, which is dr d theta, times the second term, plus the first term times the derivative of the second term, which is going to be negative sine theta. So let's just rewrite that as dr d theta cosine theta minus r sine theta. And simply what we realize here is that if we divide dy d theta by dx d theta, we get the dy dx. So let's go ahead and do that. We have a dr d theta sine theta plus r cosine theta on top, and we're dividing that by dr d theta cosine theta minus r sine theta. And once we divided dy d theta by dx d theta, we got this equation. We found what those were, we divided them, and this is pretty much going to be the equation for finding tangents to polars. And basically all that you need to do from here is, let's say you know the equation for this, you plug that in as r, you plug in the derivative of that equation here in these places, and then you'd need a point to evaluate that the tangent at, and that would be your theta. You'd evaluate it at a certain angle, and that would be your theta in this equation.